All right, let's get right into it. We're going to break down a really important update for decentralized apps. It's something that promises to make them a whole lot faster and way more reliable, tackling a problem that can make even the most incredible app feel, well, totally useless.
So, I want you to think about this for a second. You've got this amazing new game or a killer chat tool. What's the one thing, the single thing that can instantly just ruin the entire experience?
Yep, that's it.
A failed connection. It's so simple, and yet so incredibly frustrating, right? If your app can't connect, it's basically a brick. And that one single point of failure is exactly what we're going to explore today.
And for a whole bunch of apps out there, this is the absolute truth. When we're talking about real-time, peer-to-peer experiences, the quality of that connection isn't just some feature. It is the entire experience.
Specifically, we're talking about decentralized apps, or dApps. You know, these are the apps where you and I connect directly to each other, with no big company servers sitting in the middle. Think about private chats, or those collaborative whiteboards, or even head-to-head gaming. This direct connection is amazing for privacy and control, but it also creates a pretty unique challenge.
Which brings us to a really fundamental question. If there's no central server, no giant address book in the cloud, how in the world do our apps find each other in the first place? This is what's known as the decentralized delivery problem, and believe me, it just got a little more complicated.
To put it simply, they need a kind of matchmaker, some kind of service that helps two people who want to connect find each other so they can exchange the info they need to talk directly. It's kind of like a delivery driver who needs to get a message from me to you just so we can set up a direct phone call. Now, that matchmaking is handled by something called Nostr relays. The easiest way to think about these is like a huge, scattered network of digital mailboxes. Our delivery driver has a big list of these mailboxes and just needs to drop off a message at one of them for you to pick up. That's how our apps find each other.
But here's the plot twist. To fight all the spam out there, some of these digital mailboxes have put new, pretty complicated locks on their gates. They now require a special key, a kind of computational puzzle called proof of work, before they'll accept any messages. And our delivery driver, well, it just wasn't ready for that.
So this brings us to the old way of doing things, which was basically like talking to a brick wall. It was the total brute force approach that was clumsy, super inefficient, and at the end of the day, just led to a ton of frustration for you, the user.
You can just see how inefficient this old method was. The app would get a list of every possible mailbox and just start trying every single one. So when our delivery driver got to one of those mailboxes with a new lock, a proof of work relay, it would just stand there, rattling the gate, wasting precious time and energy before finally giving up. And that meant critical connection messages were getting delayed or just dropped completely.
And this wasn't just some tech problem happening in the background. The real-world result was a fundamentally bad user experience. It's that chat message that's just stuck on sending, or the video call that never goes through, or that shared document that's always out of sync. It's infuriating.
Okay, enough about the problem. Let's talk about the solution, because this is where things get really cool. GenosRTC, which is the tech that handles all these connections, just got a massive upgrade. Think of it like giving our delivery driver a brand new, super smart GPS that actually learns as it goes.
So here's how this new smart driver works. First, it instantly detects that locked gate. It sees that proof of work requirement right away. Second, it remembers. It puts a little pin in its GPS and says, hey, let's ignore this address for this trip. And third, it adapts. It immediately drops that failed attempt and reroutes all of its energy to the mailboxes it knows are open for business. No more wasted time.
I mean, the difference here is just night and day. We go from a brute force method that wastes time and energy and is slow and unreliable to an intelligent method that laser focuses only on what actually works. The result? We go from a frustrating user experience to one that is fast, reliable, and just feels seamless.
So, we've covered the how it works. But what does this actually look and feel like for you, the person using the app? Let's walk through a few real-world before and afters.
Okay, so take that decentralized chat app. Before, you type a message and just watch that dreaded sending spinner go round and round forever. Now, with the new GenosRTC, the app intelligently finds a working path, and your message just goes. Instantly. Problem solved. Or what about a team brainstorming on a shared whiteboard? Before, one person's drawing wouldn't show up for everyone else, and the whole thing just turns into a chaotic mess of Can you see that yet? Now, with a stable connection, every single stroke appears for the whole team in perfect, uninterrupted real time.
And here's a really high-stakes example, a peer-to-peer game. You're all hyped up for a match, but the connection fails during setup, and the game gets canceled before it even starts. So frustrating. Now, the connection gets made on the first try, using the fastest path. Players get into the game, and they stay in the game.
So why does all this matter beyond just making a few apps work better? Well, because these kinds of intelligent, adaptive connections are a fundamental building block for a decentralized web that people will actually want to use.
When you step back and look at it, this one update delivers 3 huge advantages. You get enhanced reliability because apps can now navigate a really complex network without you even noticing. You get superior performance, which makes everything feel snappier. And you get greater efficiency, which is so important for mobile users because it saves battery life, CPU, and your data plan.
At the end of the day, this really gets to the heart of the whole mission. The promise of a decentralized web is enormous, but to actually get there, it can't be this clunky niche experience. It has to be just as fast and just as reliable as the web we use every single day. In this update, it's a massive step in that direction.
And that kind of leaves us with one final big question to think about. We've just seen how one single smart fix can solve a huge point of friction and basically eliminate a whole class of connection failures. So it makes you wonder, how many other small, intelligent upgrades just like this are out there, waiting to be built that will become the foundation of that unstoppable web of the future?